Hello everyone, and welcome to this new Massive Worlds workshop. In this video, we are going to be talking about how we can composite props for world partition in Unreal Engine 5 using Houdini and Unreal's PCG. I'm going to be hosting this with my good friend Oscar Cerro. I myself am Erwin Heyms, and I created the Massive Worlds Toolkit, while Oscar is going to present his road propsing tool, which builds on top of the Massive Worlds Toolkit and can generate props and decals for roads. We'll then be covering how we can take the data from both the toolkit's native tools and Oscar's tools, combine them together, and then output it using PCG to Unreal's environment. Now let's get started by first introducing ourselves. So my name is Erwin Heyms. I'm a procedural pipeline consultant and Houdini teacher at Houdini Academy. I have developed the Massive Worlds Toolkit. I've been working on this for the past 3 years and currently working on version 1.2. Next to that, I'm a senior tech artist at Fracture Labs, as well as an unannounced project. And I do R&D consulting work. Plus, I have a series of video lectures currently available on my YouTube channel, completely for free, which will bring complete beginners up to speed to how they can use Houdini with the Unreal Engine. Now, as for my previous experience, as you can see here, I have been working for Ubisoft for about 9 years before I went independent. And I used to work on Ghost Recon Wildlands. I have worked on Ghost Recon Breakpoint, as well as Riders Republic. Here's Oscar. I'll let him introduce himself. So Oscar, take it away.
Thanks, man. So, hi everyone, my name is Oscar Cerro. I'm a Houdini technical artist based on Barcelona, Spain. And over the past 3 years, I've been working at Fracture Labs, mainly focused on developing world-building tools. More recently, I've started working as a freelance tech artist on the same unannounced project as Erwin. And since the beginning of the year, I've had the honor of working closely with him to expand the Massive Worlds Toolkit as a co-developer on Houdini Academy, developing plugin tools to help demonstrate and support the dressing of large-scale environments. There is a lot more to come on that front, so stay tuned. As for my background, I've worked on the Decimated project at Fracture Labs, and before that, I was a gameplay programmer on a small indie title called Soul: Search of Light.
Alright, thanks Oscar. So let's move on and let's go over to the main topic of today, the workshop. I'm going to be first presenting you a couple of things here. We're going to be discussing, of course, how we can composite foliage and props from Massive Worlds using Houdini and PCG. I'll be introducing you to the Massive Worlds Toolkit version 1.2, specifically the beta build, Vertical Slice 1, which is currently available. I will be explaining the why and how we are using PCG with Houdini. I'll be showing you how you can set up for the workshop. We'll have a hands-on section with the PCG widget, so we can actually spawn some objects using PCG. Oscar is going to cover his tool and how he's creating a point cloud, as well as the decals that are going to be covering the roads in our world. I'll also be going over the compositing tool that takes the different point clouds, including the foliage that I generate with the biome spawner, the part of the toolkit that I'm releasing today, as well as Oscar's road propsing. All these points need to be composited together, and that's what the composite props tool comes in for. And then finally, we'll do an outro, right? So let's go on. Okay, so let me introduce you to the Massive Worlds Toolkit. The Massive Worlds Toolkit is a Houdini-driven open-world framework for Unreal 5. It allows for lossless transfer of Unreal landscape data between Houdini and Unreal, and it handles the landscape in a memory-efficient way. Next to that, the toolkit externalizes Houdini and Unreal data and allows tools to synchronize in both applications. And lastly, I'm currently releasing the version 1.2 beta build, Vertical Slice Part 1. Version 1.2 of the toolkit is basically the biggest update to the toolkit that I've made to date. And it will be released in multiple stages or vertical slices, with each vertical slice focusing on adding a different aspect of the Massive Worlds Toolkit to this particular build. Now, Vertical Slice Part 1 is going to be an early access version, and it's basically a first look at the new RVT landscape material, or runtime virtual texture landscape material. It also demonstrates the new PCG props pipeline, as well as provides an example scene and cache files, so you can follow along with this workshop. Alright, so let's get started with the new runtime virtual texture landscape material. So this is a new material that is catered specifically for functioning with the toolkit, and it includes multiple sub-biomes, such as the dirt, the sand, the stone, the plants, etc. And then there can be multiple biomes. At the moment I've got 4 biomes and 8 sub-materials, but this can be increased. I think the limit that we can go to is 16 sub-materials and 8 different biomes. Still, that's a lot of different biomes and a lot of different sub-materials you can use. So, that's 1. 2, it also comes with a grass system. Now, the grass system is not fully included in the first release of this beta build. That will come in the next release, Vertical Slice 2. The reason for that is I just don't have the assets yet to demonstrate it, so I'm currently working on that. The assets that you're seeing here are actually sampled from some packs on the Fab Store, and of course I cannot include those with the release, right? So it's just demonstration purposes here. Now here you can have a look at what happens if you also include foliage with this system. So here we actually have multiple biomes blending together seamlessly from one to the other. So here we have a forest biome, and as we move further towards the coast, you're going to see more meadows, and then finally here is the coastal biome. So the trees, the grass, and the landscape material all switch from one to the other, and you can determine where each biome exists using landscape painting or by assigning it using the toolkit and Houdini. Here are some of the biomes, some quick shots of them. Here's a coastal biome. And then as we move in, here's a forest biome from within the forest, and here's from above. Next to that, because we are using a runtime virtual texture, we have the benefit of using all the other tricks that virtual textures allow, such as integrating props with the landscape by projecting the virtual texture onto the props, right? And that comes pretty much for free with virtual texturing. And we can use the virtual texture to add detail to the actual landscape itself. In this case, we are using RVT decal meshes, which project onto the landscape but aren't rendered in the main pass, and as such we can layer this detail directly into the terrain, which is cached in the virtual texture, and that's very efficient. Now here's a closer shot of the grass system. It's a highly configurable system where we can have different densities of grasses on the same material, and that's fully configurable. However, at the moment this is not yet provided. Systems are in place, but we're missing some components and demo assets. That will come in the next build. Alright, so in order to actually instantiate all the foliage that you see, we are going to be using a PCG spawner widget. This is a tool that I created in Blueprint that interfaces with the files created by Houdini, in this case Alembic files, and it loads those up and basically instantiates a grid on the world where it can replace individual clusters of trees and rocks and other props such as road props as the user requires. The tool also contains a bunch of subcomponents which can be used to clean up these grids. Now, in order to instantiate all these props using PCG, we need to prepare our data. And since we're dealing with a lot of generated content, we need a system that can composite this data together. For instance, here we have an example where we have multiple biomes blending into one another. Basically that shot that you saw earlier, but in a pure data format. So up here at the top, we have the forest biome. As we go further down, we enter in the meadows biome region. And finally, we come up to the beach biome, and each biome has its own series of props. You'll also notice that the roads are carved out because the roads will automatically call out the props in those locations. They are actually present in the point cloud. It's just that the compositor knows where the roads are, knows the size of the objects, and clears them out So once they're instantiated in Unreal, you won't have any props on top of roads, unless you want them to be there. We can also do this with other types of props, such as the road objects. More about that later. And then here is a look at the actual biome spawner. This is a subtool that allows us to configure a point cloud, one of the point clouds that we are compositing here. And specifically, this one is used to set up the spawning rules, and then this tool can be run in a task manager in the background to compute props for the entire world. It will compute them in the exact way that you've configured them, so you can potentially configure them in a very small area on your map, make sure it looks right, save it out to a preset, and then tell the task manager to compute it for the entire map. Do that for all the different biomes, run that through the compositor, and then instantiate it using PCG. And like I mentioned, here's the task manager. So the task manager basically handles for each landscape in your map, each prop set, each biome, then composites it together with any other data set, and then outputs it to Alembic files for Unreal's PCG. So for the first vertical slice of the Massive Worlds Toolkit 1.2, we have the runtime virtual texture landscape material, which at this point supports both biomes and sub-biomes and has a full runtime virtual texture integration. It also includes a grass system, but this will be completely integrated in the next vertical slice, not in this one. Next to that, we have the PCG foliage system. Basically, this allows us to spawn props and objects and foliage on our entire map, and that's what we're going to be focusing on in this particular lecture. There's a couple of other tools as well included with this build, such as the biome spawner and the compositor. I won't have time to cover everything in this particular workshop, but I'll be following this up with more dedicated tutorial videos to fully cover those tools. So stay tuned for that one. Okay, so let's move on. And just to give you a quick, clear recap of the data flow that we'll be working with here, is if we have the global props, such as the foliage that we can generate, and we have the road props generated by Oscar's tool, then those can be loaded in by the props compositor. This outputs Alembic files, and then those are loaded by the PCG widget. If we combine this with the task manager, this being the tool that allows us to run these operations in the background, it's a very simple interface. You just have to tell it to compute something and it will generate it. So this is more for your artist facing tools. So they don't have to know how everything works. They just click a button and it goes. Now in this case, an artist can configure, for example, the biome spawner, which can generate the trees for the world. This defines a preset, and then the preset is saved for each biome. When we run the task manager, we will load these presets, tell the task manager which biomes we want to regenerate on which landscapes, or all of them if necessary, and that will output point clouds for these biomes. These point clouds contain the spawning locations, orientation, and other information necessary to spawn the different meshes on the terrain. Then we have the props compositor, which also has a preset, which is also pre-configured by, let's say, a technical artist or a power user. This preset is simply ran from the task manager, so again, the user doesn't have to do anything, it just executes. And it will take all these point clouds, compile them together, make sure nothing overlaps in the wrong way, and then it outputs that as Alembic files. So once we get to the PCG spawner portion, the widget basically loads in those Alembic files by looking for the master file, the loader grid file, as I call it. And the loader grid file basically tells it where to spawn what grid of props. And this file points out where each one should be and where to find those files on disk. The PCG tool then does some corrections to the models, such as snapping them to the terrain, correcting for angle, culling them in case of steep slopes. And it can also use certain layers in the terrain, specifically the remove PCG layers, to call out specific groups of PCG. Right now there are 3 groups, and each of those groups contains a different set of objects. For example, the first group contains the foliage, the second one contains the decals for the roads, and the third one contains any other props, for example the road props like barriers and power lines and such. And then finally, we can use the tool to stamp these instance grids once they're generated into the map. This basically takes these grids and it releases them from PCG, turning them into simple instances. So let's talk about the how and why we want to use PCG with Houdini. So here's a quick example of how the tool will spawn the grids in the map. You can see PCG is executing and it will spawn each grid in sequence. It's very fast. And then we can look at the result and you can see all the instances, the decals and everything is now in place. So it's pretty straightforward and easy to use. And the benefit of this is that we can actually specify individual locations in the map that we want to regenerate. We don't even have to regenerate all of these grids. We could just select the ones we want to regenerate and only replace those. So why are we generating all this stuff in grids in the first place? Well, the main reason is will partition. And will partition is pretty much required to support massive open worlds. Now this is done because we need to manage millions of instance static meshes or hierarchical instance static meshes for props and foliage. This can mean hundreds or even thousands of instance clusters. The main benefit of this is that this will support HLOTs, or basically the fake replacement that Unreal can generate for you when a tile is not actually loaded in the scene. So here's an example of world partition in practice. Look at the back here in the background. Notice how when this circle touches that grid, it loads in a section of the terrain. Again, you can see it here. The terrain now starts to load in. And it's not just the terrain that loads in, it's also all the props that are assigned to that same loading grid. So here we have a grid of props as well as a landscape tile. And we can actually grab those grids and delete them or move them, though you probably don't want to do that. But the point is they're basically independent assets. They have their own bounding box, their own pivot, and this means that world partition can see them and load them in and out like chunks. Now, the main thing about world partition is that it will only load things that are in range of your camera. And when a loading grid touches that range, it will be loaded into memory. When it gets out of range, it will unload and eventually be purged from memory. So the main benefit to that is you can build really large worlds and only load the parts that you need. Now the way how world partition knows what to load is via the loading grid. So the loading grid is a virtual grid on your terrain that you can configure using the world settings in Unreal, the world options. And this particular grid over here, you can actually see it. When you enable preview grids over here, notice how you can see a bunch of different colored grids in the terrain. The one we're currently looking at is the yellow one. So if I shrink that down, you can actually see that right now this grid aligns perfectly with the tiles of my landscape. And the foliage grids themselves are a quarter of that. There's a reason for that, and I'll get to that in a minute. But you can also see that if I scale it up, then technically everything inside that radius will be loaded. As a general rule for these instance static mesh clusters and loading grids, we want to make sure that we turn on place small actors using location. And this needs to be enabled on the loading grid. It can actually be found down here under the advanced settings. Again, you can find this in the world settings options of your scene. Scroll down to world partition setup, and then down here under advanced. Now, place small actors using location basically tells the loading grid system and world partition that the objects should load using their pivot positions if they are smaller than the loading grid in terms of bounding size. Now, this does mean that an object needs to have a bounding volume that is smaller than the grid that it's assigned to. Otherwise, it won't load in properly. It needs to be smaller, or it will automatically scale up to the next loading grid level. Now, the reason that I made my foliage grids smaller than the actual loading grids, as you remember, they are a quarter of the size of the actual tile here. This is because, if you think about it, let's say we have a bunch of trees, right? And we have a tree on the far left of a grid and on the far right of a grid. Their point positions, or pivot points, could be right on the edge on both sides. But the trees themselves are bigger than that. They have a canopy, and that extends outside the borders of the tile. As such, is technically considered bigger than the loading grid. When that happens, Unreal will reassign this particular object to the next level in loading grids. And higher levels of loading grids basically cover double the size of a grid, but they can cover the size of a grid in any of these directions, just depending on where that tile is located. So the easiest way to prevent it from going wrong is to simply make the grids smaller than the actual loading grids. And to ensure that, I just basically cut them in half. Now, if we have a closer look at Unreal, I can explain to you why this is so important. Let's go over to Unreal here. So if we go over to our settings up here and open up our world settings, and then we want to look for the world partition settings here, let's enable our preview grids option so we can actually see the grids on the terrain. Currently I don't have the whole map loaded, only a part of it, but this is sufficient. And I'm going to go to my grids over here, and I have two grids right now. I have the main grid, which generally always comes with world partition. This will load any object that is not assigned to a specific loading grid in this one. We're going to close that for now. And then we have the second one here, which is my landscape grid. Now, if I shrink this one down, let's make this, I don't know, 20,000. Notice how at the moment it is loading the tiles that are within this circle. It's a bit faint to see, but there is a circle there. If these grids touch that circle, you notice how it will actually load them in. Now, what will happen if we have a grid, such as one of these foliage objects here? If those were bigger, as if they were one big grid, and let's say some of the trees on the borders here would technically make this bigger than one tile. What will happen is that Unreal will instead go up one level. As a result, now, whenever my circle touches anywhere, let's say on the edges of this tile, again that circle is right there, notice how it's now loading that grid over there. Now, at the moment you'd say, oh, it's only going to load maybe half a kilometer further than it should, which is not great, but not catastrophic, right? But because these tiles can technically be located in any location of these basically areas, it is technically possible for it to escalate it up to another grid level. And now, if I go over here, notice how it's already loading the objects in this particular grid level from this far away. So that's the problem with world partition and not controlling your loading behavior. So the solution to that problem is basically make sure that your grids are smaller than the actual grid itself. And then it will just load them in based on proximity. Right? Anyway, let's go back to the slide. Now, before we go into PCG, let's quickly talk about the more traditional method of spawning objects with Houdini, because Houdini is very capable of spawning various types of instances. So, as a quick rundown, there are some benefits to using Houdini. It can actually generate different types of objects, including instantatic meshes, hierarchical instantatic meshes, blueprints, any kind of actor, or even instance new geometry. Freshly made geometry by Houdini that can then be instanced throughout your map. It's very powerful. Next to that, it's very interactive because we can control it via Houdini tools running in the Houdini engine. So we can make it do anything we want, and Houdini is a very powerful toolset. We can even use it with scriptable tools because there is a set of Houdini nodes inside the scriptable tools system in Unreal that basically comes with the Houdini engine, right? So the Houdini engine gives you some options to run Houdini tools using scriptable tools, make them spawn the tool, execute the tool, and then delete the tool, and the user will never even know what it's doing. You won't have to worry about it. And then finally, HDAs can also create and organize your instantatic meshes into clusters for world partition using the Unreal Split attribute. Now what that basically does over here is you can actually see where we have a bunch of, let's say, instances per tile being spawned into these grids. And these are basically baked out from the Houdini tool, meaning that at this point they are standalone objects, right? But do note that there's a very large amount of these being generated per tile, as opposed to the single objects that we were generating in this case, where we can just select an entire bunch of trees in one grid. If we output them with Houdini in the default configuration, it will just output them all as separate actors, one instancer per actor, which is a lot of separate, let's say, render calls that it needs to actually make. A lot of actors that it has to load in independently, which is less optimized. But other than that, this is pretty practical, but there are actually some downsides to using this type of setup. The first one, and the main one, is when it comes to replacing these grids. Because it's easy to spawn them, but the moment you have to replace them, and once they are baked down, you basically have to go in and manually delete them before you can spawn new ones. Because the option on the Houdini engine interface, replace previous bake, does not replace grids based on their names. It replaces them based on whatever this tool previously generated in the last iteration. So, unfortunately, this means you can't just take a tool and move it around the world, generating a new set of objects and replacing the objects that were previously there with whatever was newly generated. What it will instead do is, let's say you generate something for tile A, then you move to tile B and you try to generate that, and it will basically delete whatever was on tile A when replace previous bake is turned on. As a result, you're basically going to end up practically with a lot of these individual spawner grids throughout your map, which means you have a bunch of Houdini tools in your map sitting around. It works, but it's not ideal. Now, you can also use task operators or TOPs. TOPs can batch render out your data, but unfortunately it's a bit more inflexible to set up and you have less control over your output. You know that nice automatic folder structure that you can generate with a standard Houdini asset? That's a bit harder to do with a TOPs asset. At least last time I tried to do this, and I've investigated this, it wasn't very easy to configure. Now, next to that, HDAs have an output cleanup process of sorts. Basically, if you leave a Houdini asset lying around with active components in it, and then you start it up, if it's in a dormant state, it first has to check whatever is connected to that tool and run a cleanup process. And as I understand it, this is basically to prevent Unreal from having a bunch of disconnected references lying around. Now, this process is necessary, but it can be a bit slow if you have a large quantity of instantatic meshes or other outputs already being generated by that tool. There are some workarounds, like disabling the tool and making it output nothing when you first activate the tool and then switching it back on. But again, it's kind of a workaround. So some caveats that we have to work with. Next to that, if we need to re-snap our objects to the terrain, this requires up-to-date terrain data. And this can be slow to sample or extract. Unfortunately, and especially in Unreal 5.4 and 5.5, extracting data from the landscape, depending on the size of the landscape, is exceedingly heavy. Not really due to a fault of Houdini, but unfortunately due to some error that snuck into the Unreal Engine in these particular versions. Now, this is supposed to be sped up again and fixed in 5.6, so I'm heavily waiting for that. But as a result, if you're just working with small tools, you don't want to go and sample large quantities of terrain using a Houdini tool on the fly. It's possible, but it's gonna sit there for a while and collect the data and then do whatever junk task Unreal's basically trying to do at that point. Now the way around that could be to cache your landscape data ahead of time, which is what the Massive Worlds Toolkit does. You have one tool, it captures the state of the terrain, and it can reference that on the fly, and that's very fast. But it is something that has to be updated. So if you're going to sculpt your terrain, you have to make a new landscape capture, which doesn't take much effort to do, but again, it means you have a little bit of iteration to go through. And then finally, let's talk about artists, right? If you are an artist that doesn't know Houdini, and you don't really want to deal with too much of the Houdini engine, and that's common, right? Regenerating your foliage and props using a bunch of Houdini tools, when you have to jump through a bunch of these hoops as well, is just impractical. Or at least, they won't want to do it too much. It's going to slow down their iteration speed, and that's never a good thing in production. So all in all, Houdini is very powerful for spawning instances and objects. However, for our purposes, where we need to spawn a very large quantity of foliage across our world, we need to have it work with world partition, which means it needs to be cut up into easily loadable and efficient grids. It needs to be easily replaceable if we want to work with these grids. We don't want to have to generate everything all the time. And we'd like to avoid using Houdini tools that have to boot up and etc. When we just want to replace some foliage or snap it back to the terrain. So what's the solution, right? Well, the solution can be by using PCG, if we manage it properly. And let me quickly run you through some of the reasons how we're going to go about doing that. Firstly, PCG can actually generate your props live, meaning they can be computed in-game at runtime. However, for, let's say, practical reasons, this is often not very useful. You can have issues with the objects not existing when the server needs to know where they are. Or maybe for one person they exist on their system, but they don't exist for another person. Like how to track that, especially in a large open world. So maybe for the time being, this is more practical for smaller projects or very specific cases. If we think about PCG, we often think about this on-the-fly live generation of our content, right? Being able to replace entire worlds all at once using a generational system. It can technically do that, but for practical reasons, and because PCG is still pretty young, it's still not quite there yet. At least I've heard from a bunch of people that when they try to apply it in their projects, they tend to back away from the runtime portion of it. I'm not saying you can't, and I'm not saying Epic isn't improving this, but that's something to note. Next to that, for Massive Worlds, where we have millions of instances, it might not be practical to spawn everything on the fly. This can be for multiple reasons. For instance, how would the server know where the objects are and where their collision is if they don't exist in any form of data, right? Would the server have to sort of analyze this, and where would it know where to look for it? So it's much easier for a server and for any kind of game logic in general to already have pre-cached data available as opposed to rendering it on the fly. Again, this might not apply to every single case, but in our case, it definitely does. So in our case, what we can do is that we can actually generate and then disconnect our instance static meshes, and this process is called stamping. Similar to Houdini's bake option. Houdini generates something, we bake it out, and then it becomes a standalone object disconnected from the Houdini engine. In terms of PCG, this is similar. We can generate something with PCG, it's still connected to the actor that generated it, and then we can stamp it out, or let's say disconnect it from the generator, and that will generate a new PCG stamp. We can then clean up that stamp, give it the correct name, put it in the right folder, and Bob's your uncle, you've got your new instance. Now, PCG does have a built-in grid splitting system called PCG World Actor. If you've ever used PCG, you might have noticed this thing pop up in your outliner the moment you generate anything with PCG. This is more to manage which objects get generated and which don't at runtime. It doesn't really help us in this case. We are going to need more control. So let's talk about the requirements for our particular approach. So the first thing that we need is we want to use Houdini generated data and instance that via PCG. Now you can actually use PCG to generate the objects directly without even using Houdini data. However, PCG is still pretty young, and in general I've found working with PCG comes with a lot of caveats. You need to know what works and what doesn't, what's stable and what isn't. And while you can probably set up a pretty complex spawning system using PCG, making that also configurable is probably a much taller order. On the other hand, with Houdini we can create very complex spawning tools which are highly configurable, use external data, and in general Houdini is a very developed out programming language, so we can do a lot with it that currently is just going to be a lot harder to do with native PCG. Now next, we need to be able to easily create and replace our instance grids. If we're going to be generating some grids in our world, and we then want to spawn new ones because we've changed our distribution, we don't want to have the old grids still sitting around and doubling up our objects, right? So that's important, and we want to make this as seamless as possible. So speaking of which, we want this to be as artist friendly and as mistake proof as possible. Like I said, the Houdini tools do need some know-how to be used and knowing what works and what doesn't. We want to have a simple interface that the user can just go through and click, 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 and it's done. Maybe with a bit of extra knowledge on how to use it more refined, but in the simplest way as possible, we just want it to be press button and go. And finally, we also want to make sure that the system configures everything without having to touch any of the subsystems inside these instances. If we want to configure things like the HLOT layer that they belong to, whatever loading grid they're assigned to, we want to set up our collisions, we want to configure RVT decal systems, or where in the outliner it's located and what name it has, all of this should be done for us. That's important because if you have hundreds or thousands of these in your map, you really don't want to have to go through all of them and manually tweak them, right? And yes, of course, we also want to have artist control. So for instance, if we can use a landscape layer to paint out an area where we don't want foliage to spawn, then the PCG tool can automatically call out, let's say, certain types of foliage in that area. We can use layer density to control which set of foliage, or let's say which set of road props or road decals get removed. So we can artistically control the density of our forests. We can clear out areas for custom content, or for example, we can clear out the road lines in an area but leave the detailing on the roads intact. Alright, so now that we've discussed the necessity of PCG and how we want to use it, let's talk about how we can get our data from Houdini into Unreal, so PCG can actually spawn our objects. Well, firstly, we're going to be using Unreal assets, and the data that we're feeding to Unreal points to those assets. We can store this in two different types of data. We can store it using CSV, or we can use Alembic point clouds. Now, I would highly recommend that you use Alembic point clouds. When I first started out, I used CSV data tables for the system, and frankly, the only benefit to them is that they can be stored internally in Unreal in data table format. However, generating them, importing them, and saving them is exceedingly slow if you have a lot of props. Basically, if you go over 50,000 actors, and you can easily reach that level in a 500 by 500 meter grid, these files become slower and slower to work with, let alone open up. On the other hand, Alembic point cloud files are actually really fast. They can be fast to create using Houdini, and they are very fast to load by PCG. I mean, technically, if you make the file really big and include millions of points, it will still take a moment for PCG to load it. But since we're cutting it up in individual little grids, you're never going to get to millions of points per grid. Next to that, it does, however, mean that we need to store our data externally as ABC files. Alembic files are importable into Unreal, but only in the model format. It doesn't work with the point cloud format, which is the one that we're using. Unreal simply won't recognize it. So what we're going to have to do is point Unreal to a file on disk and then have it load the data from that. However, since we're loading our data in the editor, that doesn't really matter too much, and I've set up the system in such a way that it will always know where to look. Now, the other thing you need to know is that it requires the external data interop plugin or interoperation plugin, which comes with Unreal. It's just not enabled by default, just like PCG. So you have to make sure this plugin is activated, or the tool will simply not work. So the way how we're going to make this work, without it being too much of a hassle, is we are going to make Unreal point to one specific Alembic file. This Alembic file then contains the location and names of every other grid that PCG can potentially spawn. So this one's basically an index file, and these are all the point cloud files. Firstly, let's talk about our spawn point clouds. These contain information such as the mesh reference, the transforms, and the spawning rules for each grid that we're trying to spawn objects for. This basically means that we end up with a bunch of Alembic files named based on the landscape, the grid coordinate in that landscape, which quadrant in that grid it's in, and then the layer that it belongs to. And when I say layer, I basically mean that we can spawn our foliage, our road decals, and our road props separate from one another, so we don't have to replace all of them at the same time. So we'll basically end up with a bunch of files named like this. And then we have the loader grid file, which contains the position, the bounding shape, and the names of all those other spawners. Now, one thing that I do here is I actually save it in a separate folder called full. So we have our cache over here. This contains all the cache files for landscape 2. This one contains for landscape 1. And then this one is a shared folder, which is where this grid loader will be located. So we only have to look for this particular folder for this particular file, and PCG will just grab that, and that will point to the locations everywhere else. Because we are using the Unreal project folder as the base structure, and all of these files are located within the Unreal project folder, this will work out the box. If you have your Massive Worlds cache located somewhere else, you'll have to configure the PCG spawner to look there instead. But either way, the tool will know where to find the files fairly easily. Alright, now for the next portion, you're going to have the toolkit installed on your system. So let's go over how we can do that. So let's go ahead and download the Massive Worlds Toolkit from my Patreon page at patreon.com/ErwinHeyms. On here, you should be able to find a post called Massive Worlds Toolkit version 1.2 beta Patreon download. And in here, you'll be able to find all the files required to follow along with this workshop. Now keep in mind that of course this particular download is only available to my Patreon backers. And version 1.2 is going to require you to be subscribed to the Massive Worlds backer tier, which is €22 a month. Now, I will say this, you don't have to stay subscribed in order to be able to use the toolkit. You can subscribe, download it as is, and then unsubscribe. However, I will be releasing more updates to the toolkit over the next few months. And of course, if you want to get access to those, you will have to be subscribed to my Patreon. Now, once you subscribe to my Patreon, as a backer bonus, you will get access to the toolkit using a non-commercial license. However, of course, this is only a non-commercial license. If you're going to use it in a commercial setting, there are some conditions that once you exceed those thresholds, you should contact me to get a license. More about that later. I don't want to bog us down. And of course, you're going to get access to the project files and Houdini digital asset download links. You'll get access to future releases of the toolkit, assuming that you stay subscribed. And there is a specific Discord channel for backers where you can leave feedback, ask questions, and where I post live updates as I develop the toolkit. So at this point, I assume that you've gotten access to this particular Patreon post. So go down and scroll down to the bottom and download all 6 of these files. Now these files each contain parts of the workshop. So the first part here is the main Unreal project. There's a patch for it, and there's also the HDAs, which have a password which is noted down here. Now once you've unzipped the main project, you'll get this folder structure. Then go ahead and also unzip the patch and install it into the content folder. It has the same structure as the content folder, so it should be fairly straightforward. There's just a couple of files that need to be replaced. And then next to that, we have the HDAs. So if we grab the HDAs, you can unzip them and then install them into the Massive Worlds folder, HDAs. Just go ahead and do that, and that should make sure that they're all properly installed. Now at this point, we are almost done installing the toolkit. We just need to set up the JSON file so Houdini can see all its components, specifically the cache for the Massive Worlds Toolkit, as well as the HDAs that we just installed into this folder here. Now to do this, you can find the JSON file that I've provided with the download package. So go ahead and copy that, and then you'll want to go to My Documents, Houdini 20.5 Packages, which you can find, let's say, over here. And if you don't actually have a Packages folder yourself, go ahead and create it. If you are running a newer version of Houdini, let's say a future version like Houdini 21, go ahead and put it in there if you don't have 20.5. And then you'll have to create a Packages folder here and then paste the JSON file here. Then if we open that file, you then want to specify in what folder you've actually unzipped your entire project. So in this case, if I'm going to be working with this particular project folder here, with this Unreal project and this Massive Worlds folder structure and cache files, we're going to want to grab this particular folder's path. And then we can put it up here under the per force field. Go ahead then and save, and that will correct the file path, so Houdini will be able to see all its files as well as the HDAs. Now with the project, I've already provided to you the Houdini engine for Houdini 20.5.550. If you actually go to the plugins folder in the project download, you'll find it here. Now, if you are running a newer version of Houdini, you will have to replace this particular set of folders. So to do that, you'll want to start the Houdini launcher and then navigate down to the Engine Plugins tab and go to the version of Houdini that you want to run this on. So let's say we want to grab the plugin for 566, if that's the Houdini version you have currently installed on your system. Then you go to the gear, to details, and then grab this file path. We can then close this, and if we grab a browser here and we paste that link in there, then here you'll find the different versions of the Houdini engine for different versions of Unreal. We're running Unreal 5.5.4 here, so I'm going to go in there and copy these folders, and I'm going to replace these guys with them, right? So we want to delete those and then paste the Houdini engine in here. Assuming that you've done that properly, the Houdini engine in Unreal should be able to run. And of course, in order to actually run the Houdini engine, you are going to need at least a Houdini in the license, right? You can't run the Houdini engine with a non-commercial license. Alright, so at this point, if you've installed the JSON file properly, you should be able to have Houdini see the files for the Massive Worlds Toolkit for both Houdini, the Houdini engine in Unreal, and the Houdini PDG. And I'll be able to access these particular folders in the toolkit. Let's have a quick look at how this works. I won't go on for too long, but basically you have this folder here for the Massive Worlds Toolkit, which is included with the actual project folder. This includes all the cache files that we are going to be accessing, such as the point clouds for all the props in our world, right? As well as other information such as landscape information and biome information if you want to run the biome spawner, for instance. Now, inside this folder, you're going to find a bunch of different file type folders. These folders are basically the external cache for the Massive Worlds Toolkit. These are used by the toolkit to communicate data between its components and Unreal. Now, if we jump into one of those, you'll go down to the project level. If you have different landscapes in your world, each landscape basically comprises what I call a project. So you can have multiple landscapes in your terrain that are all sitting next to each other, and they all have their own project name in this folder structure. You can also add your own project names in here that aren't related directly to a landscape, but could, for example, be used for files that apply to all landscapes. Now, if we jump inside one of these project folders, you'll get to the actual caches that are part of that particular folder structure. So here, for example, we can find the cache folder for landscape 1, in which we have the path blueprint spline cache, the path grid cache, as well as the prop caches and the alembic files that we're going to be using with PCG. Alright, let's go ahead and boot up the Unreal project. So let's open up our browser here and let's go to the Unreal project. Let's start that up. And once that's booted up, we will have access to this particular scene. Go to the maps folder and go ahead and open up the example map 1-1. Now it might have to cache some shaders initially, but once that's done, you should be able to see this map. Now at the moment, it's only going to be loading a small portion of the terrain. So if we go to World Partition, you can load more. But for the purposes of this particular lecture, you don't have to. Well, there are some tools in the scene that are currently not being loaded into memory. Let's increase our camera speed so we can actually zoom around a bit. But let's say we load this part of the map as well. And we'll give that a second to catch up. Now, depending on your memory, on your video card, you don't have to load the whole map at once. You can only load small sections of it. Though I do suggest that you run this on a decent graphics card setup. I personally have a 4090 RTX. I don't expect you to have that level of card per se, but it's still useful to have sufficient memory available when you're working with large landscapes, because they do take up some VRAM. Alright, so the tools in question are back here. These include the biome spawner tool, which is used to specify, let's say, tree distributions for various biomes that we can spawn. And we have the compositing tool back here, which is used to composite various point clouds together, such as our different biome caches, the road props, as well as the road barriers. We'll talk more about this a bit later. Now, first we want to test out if everything's running properly, so go ahead and go to the Houdini engine and try to create a session. And if it says Houdini engine connected, that means your Houdini engine is running and you should be good to go. Now, we are going to be using the widget, and you'll be able to find that one here under Content, Massive Worlds, which is where all the Massive Worlds related tools and files are located. And then here's the PCG tools folder. And you'll be able to run the spawner widget by right clicking on it and saying run editor utility widget. If you've installed the patch correctly, you should see this particular version of the widget. Alright, let's go ahead and use this widget to actually spawn some PCG. Now, before I do that, let me go ahead and clean up my scene a little bit. I'm going to grab the widget and move it up here into this window. Next to that, let's make this a bit smaller. Make sure we have some space here on the right. And let's move over here to the center of the map. Now, you might notice that I have loaded the entire map at the moment. You don't have to do this. I just need to do this for some demonstration purposes. So I've loaded this part of the map as well. Okay, so let's go ahead and spawn some PCG. First thing we need to do is generate a grid. Now, I'm going to go through this process pretty quickly initially, and then we'll go into some details on these settings over here. So first thing to do is to click on number 1, create a grid of spawner BPs. If we do that, we're basically going to create a grid in the middle of the map based on the data that's available in our point cloud cache on disk in the Alembic file cache. Now, this grid on its own is loading 16 different subgrids, or in effect it's loading 4 of them, but it's cutting them into quads, right? Now, on the right, you'll notice that it's created a loader grid file, and it also generated a bunch of spawners. Now, these are basically blueprint actors with a PCG component inside of them. The loader grid here, if we look at that guy, is loading the loader grid file as is specified up here on the widget. It has a spline component in it, and then next to that there is a PCG subcomponent that's loading the loader grid PCG graph. Now, that basically means that this PCG actor is generating a bunch of spawner blueprints. These spawner blueprints here are each equipped with some box graphic elements that we can use to select them and that determine their bounding area, basically the area of effect for PCG. But it also contains its own PCG component, which uses the PCG spawner graph. So this guy is the one that will actually spawn some objects, but right now it's not spawning anything as of yet. To make these grids spawn something, we can go to their own interface and click on load grid, and that will actually make that object generate some PCG for us. As you can see, we can make it spawn and clear. But this is not the preferred method of spawning our objects. We don't really need to go and do this manually. That's what the widget is for. So let's go back to the widget and let's do this via the interface. So once we generated our grid, we have a bunch of spawners here, but they're all unnamed, so they're not very organized. What we can do is we can trigger the spawning behavior as well as a renaming piece of code that will name these grids based on the file that they're all loading. So let's grab that, click on that button, notice how they're all renamed, and at this point if I go ahead and select the children of the loader, so all the spawners basically, notice how it's now spawning all these grids using PCG. And these objects are in the exact same position as they should be in the points that Houdini has provided. The only difference being is that it does do some cleanup operations, such as snapping them to the terrain, if the terrain is any different, realign them to the terrain based on some internal information provided in the point cloud. It can cull them based on steep slopes, and it can also cull them by a layer weight. And the layer weight is something we'll be looking at in a moment. Okay, so now that we spawned some objects, let's go ahead and stamp them in. Because at this moment we actually do have existing trees in these exact same locations. In fact, if I hide my loader grids, notice how we still actually have stamped instances in the map in the same location here. In fact, if I go ahead and grab one of these and I move it up a bit, and then I unhide my spawners, notice how they are both present. Of course, if we were to just stamp these guys, we would have two sets of trees, so we need to run some cleanup operations. To do that, first we need to actually stamp our output. So if we go back to our loader grid here, and we click on Stamp Spawned Instances, what it's going to do is it's going to grab all these grids, whatever it's generated at that time, and it's going to output it from these spawners, meaning the spawners get emptied, and it's going to output them as PCG stamps. Now Unreal's not going to give these things names, and thankfully in 5.5 it's now actually giving them unique IDs. Before it didn't even do that. But basically these are now separate instance objects. In fact, if I click on one of them and I go to details, you'll see here is one of them with all its instances. But they've not been properly configured as of yet. For example, if I look at this guy, notice how it has a really big scale and its pivot is also located somewhere in the sky. And that's simply because it copied the settings from the PCG component up here when it created the instances. There's not much I can do about that, but I can clean it up afterwards. So that's what we're going to do next. We're going to organize these guys. Now we can do that by clicking, nothing at all, and then going to the widget and then saying organize stamped actors. If we do that and we make sure all this auto cleaning stuff is enabled, it should clean them up. And I say should because there is a caveat to this. I'll get to that maybe in a moment. So if I click that, notice how it has now replaced these actors. Now you won't be able to tell that, except those trees that were here previously, that were in the sky, are now gone. So what it's basically done, and maybe this is easier to show if I repeat this process, but basically what it's just done is it's taken those stamped actors that were here in the outliner at the bottom, and it's moved them into the instances outliner folder. Here you can see we have a bunch of stamped instances now with a star next to them, meaning these are new, right? All of these were just created, and it selected the old ones that were there previously, it's marked them for delete, and it's replaced them with these new ones. It's also renamed them, and internally it has fixed their scale, and their pivot is now nicely located in the middle of each grid. So that's the main basic behavior of the cleanup process. It basically tries to make sure that all our objects are nicely organized, cleaned up, have all their settings configured, etc. Now, let me just show that one more time, but this time I'm going to do it to just one grid. So let me grab one of these. Let me say you there. Now I'm going to make sure I have a grid selected with group 0, which is one of the trees, right? Group 0 is the foliage. If we actually look at the widget, that will be layer A. So if I have this guy selected, well, at the moment I'm selecting the spawner, but you'll notice that there is nothing spawned. That's because we already stamped out its contents and it's currently empty. All the other spawners are still around. They're currently just, sitting around idle. If I go ahead and I click again on rename and spawn PCG instances, then it should spawn something, but notice that it's already been renamed. So in this case, we can also click on force respawn selected grids. That will force it to update. So if it doesn't update with this, it's probably because it's already spawned previously. Click on this button and it will do it instead. Okay, so notice how I've only generated one grid right now. All the other ones are still empty. And that's simply because I only had this guy selected. So the widget is sensitive to whatever you have selected in the outliner. If you have the parent selected, it will grab all of them and generate all of the grids. If you only have one of the children selected, it will only generate that guy. Okay, so let's go back to the one we just generated, and let's make sure we don't grab the instances. In fact, notice that this one's the one we just saved out. I'm going to just move this one up again, so we can at least see the differences. So here's the spawner under the loader grids, and let's stamp that one out. Okay, so once again, we have our stamped PCG actors down here. And if we now click on Organize Stamped Actors, or if we select this guy and then click on Organize Stamped Actors, again, notice what happens to the trees that are here in this position already. They get removed. Okay, so that's what this does. This auto clean existing instance grids. Now this only works if the grids that are already in the map, such as, all of these guys here, are visible, loaded, and editable. So if you have them in checkout on Perforce, or rather if someone else has them in checkout on Perforce and they cannot be deleted, you might end up with doubled up grids. Or if for whatever other reason those grids aren't deleted automatically, you might end up with doubled grids. Likewise, there are still a couple of bugs with the blueprint script that the widget executes. I've tried to clean this up. I'm still not quite sure what causes it, but sometimes when you organize your stamped actors with the center pivot option enabled, they can end up in the sky. And I don't know if I'll end up showing that today. But one of the ways how we can fix this is by not running that cleanup script when we are organizing it, and then afterwards selecting the objects in the up here in the outliner, and then running that cleanup script manually. So we can actually trigger these cleanup scripts here manually as well. So I could click on here on this button and it will run the cleanup script on these guys. Now, let me demonstrate that, for instance. Let's say we generate one of these grids again. Let's say you guys. Yeah, all of these will do. Okay, I'm going to spawn them. And then I'm going to stamp them. Alright, so now we have some stamps down here. And I'll go ahead and I'll disable my cleanup scripts down here. Also notice how there is the HLOT option. Currently I don't have a HLOT in my scene, but if you have a HLOT layer you want to add these objects to, you can feed it in here. If I now click Organize Stamped Actors, it is not going to delete the previous actors in the scene. Likewise, it will not fix their mobility and collision, and it will also not fix their pivot positions. So let's do that. So if I now click on these objects and I look over here, you'll notice that there are a bunch of duplicates sitting in the same location in the world, right? Now, that's a problem, of course, and this can happen also for various other reasons, like I just mentioned. It might be that the object wasn't loaded properly, or it wasn't visible, so the cleanup script couldn't see it. If you want to fix this after the fact, just make sure you have nothing selected, and then click on Select Double Instancer Grids. If you do that, it will select all the older instancer grids, and you see here it's found 4 of them, the 4 that we just generated, and it's selected the older versions of those duplicates. It will only leave one of them, the latest one, unselected. So at this point we can just go and click on Delete. And that's another way how we can clean this up. It's pretty useful if you just want to run a cleanup operation on all your grids, make sure that you don't have any duplicates anywhere, and that's fairly straightforward. Now next, let's go ahead and clean up their pivots. So like I said, it is possible, just go ahead and select all of these and clean up their pivots. So if we grab some of these, we know that their pivots weren't fixed, right? We can of course just click on Center Pivot and 1-0 Scale on Selected. If we do that, it will fix the pivot. Yes. So do that again here. Click on that. It doesn't immediately show, but if we deselect it and we select it again, it will fix it. Well, you will see that it's been fixed. So we can actually run this on the entire batch if we need to, and the ones that aren't fixed will be fixed. Likewise, one thing that PCG doesn't seem to do properly is set the mobility state of the objects inside. They will all be set to movable for whatever reason. As well as their collision should just be block all instead of block all dynamic. In general, you want these trees, when they're in the world, to not be dynamic objects. You want them to be static objects, because that's way simpler and way lighter for your game, because you're going to have millions of them, and you really don't want to have a bunch of dynamic objects sitting around. So that's what this step is for. Let's again select whatever we wanted to clean up. I'm selecting a couple of double ones, but that's okay. I'm going to go back to the spawner, and I'm going to say convert selected instances to static. If we run that operation, and again we go back to these trees, notice how now, if we go to mobility, they've been set to static, and their collision type has been set to block all. So it's no longer a dynamic object, and this is better for your game. So that's basically how the manual cleanup process works. In general, you don't need to do this, you can run these guys, but I have noticed that sometimes, especially the pivot cleaning process and sometimes the auto cleanup, can fail, and it is probably because Unreal is hitching or something causes the blueprint loop to fail. Honestly, I've tried to clean this up a few times and I still haven't gotten it quite figured out. It doesn't happen all the time, maybe once out of 10 times, maybe once out of 5 times. Might depend on the strength of your PC, might depend on whatever it's doing at the same time. If I figure it out, I'll fix it. I'm still committed to trying to fix that. But anyway, you can run these things manually as well. It just takes a few more clicks. right? But honestly, I have generated entire maps worth of trees with just the auto system. And if it fails, you can generally just go and re-stamp them again. Just regenerate, stamp, and organize, and it'll be fixed. Anyway, let's go ahead and clean up our spawner. Because now that we've spawned stuff, we can now get rid of the spawner because we no longer need it in our scene. In fact, I recommend you don't output this to your build. You don't want this in your runtime game. It is not meant to be a runtime tool, and you'll probably get some errors with validators or whatever if you do. So to get rid of it in a clean way, you want to go to the loader grid, and you want to scroll down to delete loader and spawner. Click this once, and it will delete all the children of the loader grid, meaning all the spawners. Click it again, and it will then also delete the loader grid actor. Okay, so that's a way how you can clean it up. Now let's go ahead and save. So if I go ahead and save my scene, notice how a lot of these actors have duplicates here. Some are being added and some are being deleted. That is exactly what it's supposed to do. It's basically generating new grids and marking the old ones for delete. So we're basically swapping them out with new ones. So let's go ahead and save this. And if you've done everything properly, at this point you will have a new set of grids in your map with foliage, as well as probably some of these decals here. And they are freshly spawned and updated. Now, you're not going to notice that right now because we haven't actually changed anything compared to what was there before. So let's go ahead and figure out what we can actually do with the landscape tools to manipulate our PCG. Because there's another reason why we can use PCG to spawn our objects. So let's go over to this village over here. It's right next to the lake. Let's just zoom in on that. I'm going to hide some of these visuals here just to get them out of the way. Now, we can actually make PCG generate when we are manipulating the landscape. You generally don't want to generate too much PCG at the same time because it will cause the PCG to update no matter what part of the landscape you're manipulating. That seems to be a thing. But we can use it to see what PCG will do and how these objects will end up if we actually manipulated the terrain in some way. So let's go ahead and spawn some new PCG in this particular area. I'm gonna grab the tool. Let's spawn a grid. And let me grab this guy. And I'm just going to make the spawner grid a little bit smaller. I'm going to grab these points. You can use Control. And you can select a smaller area. I'm going to move that over this town here, roughly. Say about here. And click Regenerate Grid. Notice how it's now generating half the size of that grid. It's just right on the border of these two grids here. So it will load both of them. That's fine. The main reason I'm doing this is because it means I have less PCG to generate and the feedback will be just a bit faster. Now you do notice that I can use this particular bounding shape to select a large quantity of my terrain at once and generate all of that. I can also grab this, hold Alt, drag out a new point, and make an even bigger grid, and then regenerate just that area. So if I want to regenerate this lake, I just have to draw a curve around the lake, and all the grids in this area will be part of the update. Now let's get this back to normal, or the way how I just had it. Let's move it back here. Incidentally, if you want to generate the whole map at once, you can also disable limited spawner grid by bounding. If you disable that and you then generate, it will create a grid for the entire map. It'll take a second, but this is basically all the grids that are available inside the point cloud cache. that are indexed by the loader grid file. We can also tell it to only generate, for example, the RVT or the props. So if I disable my foliage and I then generate, it will generate the grids for those particular instances only. It will only generate grids that it has points for. So, you know, that's one thing to take into account. So let's go back, generate just this area, and let's have a closer look at how we can manipulate our terrain and have PCG update live. So I'm going to go ahead and spawn some of our PCG here. Now at the moment we do have existing trees in this area, and if I'm going to be looking at live PCG, I don't want to be looking at both of those at the same time. In fact, let me select these guys, and if I hide them, we still have trees in the same place, right? Let's go ahead and click on hide existing instances if we have these grids here selected. We do that. Notice how it's hiding the actors that have been previously stamped in this location. It's still leaving the other ones visible, but the ones in this location have been hidden, which means that if I actually unhide my loader grid here, the only thing I'm currently looking at is live PCG, meaning that I can manipulate this and I will see the latest result only. Okay, so let's make the screen a little bit bigger. And I'm going to open up the landscape editor. Now, this might take a second to update, depending on if you've already opened up the landscape editor previously. I do suggest that you let this load properly. Now I'm going to go to the base layer for now. I'm going to go to paint. The reason I'm selecting the base layer is because a lot of the layers for painting go into the base layer. There are a couple of exceptions, and I will present a proper set of documentation about this with version 1.2 in the future. It's just that at the moment I don't have that quite ready yet for public release. Anyway, in here we can see all the layers that are available to the new landscape material that comes with the Massive Worlds Toolkit version 1.2. And the ones we're currently interested in are down here, the remove PCG layers. Now at the moment we can't see those yet. Now there is a way how you can actually see layers in your landscape editor, but it basically involves changing your view mode to go to Visualizer, Layer Debug, and then you can turn on the layer that you want to visualize, kind of like this. Okay, so right now I'm viewing the remove PCG layers that I have painted into this scene. Now the problem with this, of course, I cannot see the actual terrain texture at the same time. I mean, I can bring about my visualizers and view it this way and maybe go into unlit mode so things aren't blinding. But it's still a bit of a cumbersome way of working, right? So I'm going to turn this off again. Let's say we go back to visualizers and set it back to normal. Let's go back to lit mode as well. And instead, I'm going to go to my landscape material. So to do that, I'm just going to exit landscape mode for a sec. I'm going to select my terrain. Make sure I select the parent of the terrain. And then in the details panel, if I scroll down a bit, I can double click here to open up the landscape material. Let's do that. And let's pull it over here. So this is the landscape material. There's a bunch of settings in here, including settings for each of the sub layers, for the different biomes. We have a bunch of different controls in here that you can play with. But the main thing that we're looking for right now is debug. So let's open that up. Now debug allows us to see information about various things in the landscape material. The one we're currently interested in is the preview for the RVT removal layers. That's already enabled. If we go over here, let's set our debug strength to, let's say, 0.2. Okay, so at the moment that's enabled. And you can see how we now have a couple of different colors appearing on our terrain. I'm just going to go ahead and hide these visual elements again, just to make sure they're not in the way. Alright. Okay, so at the moment I'm looking at debug type 7. There's a bunch of different debug modes in here. Some of them are related to the grass system, so you can see the different layers and the densities of the grass. There are modes for viewing the biome and sub-biome distribution, the layer weights basically. Let's say we're currently going to be working with mode 7. Okay, so mode 7 displays our remove PCG layers. Now at the moment, for that one, we are looking at mode 3. So mode 3 basically shows us the remove PCG layers as RGB, similar to how we were just looking at it in the standard debug mode. We can also view individual layers. If we set this to number 0, we will view only layer A, meaning the foliage removal layer. And notice how in this case we can actually see the density of these layers as a gradient. And you can also notice that the gradient is different, and this is causing PCG to be removed in, let's say, different ways. For example, in this area only the trees are removed, but these bushes are still in place. Whereas in the red area all the trees have been removed. All the objects are gone. And that's actually intentional. If we switch to mode 1 here, you can see that here it's removing the decals on the roads. So here you can see that the decals for the roads don't spawn here. And if we go up top to this area, and we switch to mode 2, you can see that here the road props are being called out. So that's how this works, right? This is basically a preview system and allows it to see different information about the material and how, in this case, it's affecting PCG. Okay, so let's go ahead and do some of this. I'm going to leave it on mode 3. And then switch back to the landscape editor. Alright, so now we're in the landscape editor. Let's select the base layer for painting. Make sure we're on landscape 1. And I'm going to, let's say, disable this and scroll down. So now you can actually see we have layer A, B, and C here. Let's grab layer A. And let's go ahead and remove some of this culling here. So if I hold Shift, I should be able to remove this influence here. And if we wait for a second and let PCG regenerate, notice how the trees have just returned, right? That's basically how the system works. We have a lot of points that have been generated by Houdini. The composite tool has generated a large quantity of spawn points, and then PCG will instance those, but we have the ability to cull them out. So for this village, for example, I didn't want any trees in the middle of my town, so I've removed them in this area. Likewise, if we want to remove some of the road propsing, we can also do that. But like I said, it goes slightly further than that, because these objects have a culling weight baked into them. This actually comes from the data table for the biome spawner tool. Specifically, if we go here to the sub-biome spawner data table. Yes, it went through a name change. It used to be called sub-biome spawner, but I found that a bit convoluted. If we look at these particular, let's say, spawnable items, and we scroll down, here is something called max cull weight. The large trees have a max cull weight of 0.15, meaning that if we paint a value of 0.15 using the removal layer, those objects will be removed. But if we look at the smaller objects here, like the bushes, those have a culling weight of 0.75, so they won't be removed until we reach a layer density for the removal layers of 0.75. Now the same thing can be done for the road decals as well. I don't think that at this time they are properly configured yet, but the idea could be that if we want to remove just the road lines, right, just the lines on top of the road, but not any of the potholes or other detail decals that we might want to put on our terrain, then we can use that. For example, we could paint only 0.25 influence in this area, which might remove the lines, right, but not the other decals that are being spawned on top of the road. This will become more prevalent in the future, but it's a way how you can control ahead of time what will be culled at what density based on whatever you've configured into your point cloud, and then you can use the PCG removal layer as an artist to simply remove whatever you need to be removed. So in this case, if we were to paint a value of 0.5 in this area, it might remove these lines, it might not. That honestly depends on the settings inside the instances. Now, this isn't only limited to these removal layers. We can also, of course, use it to move our objects up and down and see what it will look like if we move the terrain. So in this case, I'm going to go to sculpting and I'm going to go to my micro layer. There's a whole document that I have about how to use the layers in combination with the Massive Worlds Toolkit and how Unreal operates with landscape layers. I'll be releasing that in a future release. It's not quite ready yet for a public release, but it will hold a lot of information about how to use the landscape layers with the toolkit. Anyway, for the time being, let's go ahead and sculpt a little hill into this area. So if I move this, normally these trees will be underground, right? But if we have active PCG going on in this area, they will be moved up. Now, I just want to make sure that our old trees are currently hidden. There are still some plants underground though, so I'm guessing some of them are currently not hidden. Let me just go ahead and fix that. Let me go ahead and select my spawners again. Go to the widget and let's hide existing instances because I think I accidentally unhid my actors. There we go. Okay, so you can see how we can move our terrain about and PCG will update for us. Likewise, if I make a really steep cliff for whatever reason, let me just make this slightly stronger. Then that tree on that side of the hill will likely be removed because it can't exist there. This cliff is too steep, right? So that's what the steepness function in the PCG tool is all about. In fact, if we go over here, we do have a bunch of settings that we can turn on and off, including the cull by layer weight over here. We can control snapping to the terrain, realigning to the terrain, and culling by slope. There are some attributes that we can set on our objects to make them ignore these options, like some objects, such as the objects next to roads or whatever, probably should not be realigned to the terrain at any point in time. So we can control that via an ignore attribute as well. Anyway, that's basically it for the spawner. We've gone over these options here. We've gone over the different spawning options and we've gone over the manual cleaning. So that's pretty much that. There's one thing that I might still want to mention is this option here, clipping distance by size category. This basically involves how the PCG spawner itself works. So if I go to my widget, let me grab one of the spawners here. Let's grab its PCG component and let's open that up. So here's actually the PCG code that spawned the objects. This is one of those grids. And I basically had to work with what PCG could do in 5.4 and Maybe in 5.5 it's a little bit more stable, but I've still noticed there are some instabilities that I had to work around. So yeah, like I said, PCG is still a bit early, but still, this basically loads the Alembic files. It goes through the system. We can call them by the bounding of the actor. Then we can snap it to the terrain over here, snap and inset to terrain. Here it does the remove PCG layer weight. And there's a bunch of well, a bunch of filters here, simply because comparing two attributes to one another is a bit tricky in PCG. So that's how I did it here. There's align to landscape. If we go up here, we have filter by angle. That removes objects if they want to steep an area. And then finally, here are the spawners. So we have spawners for, for example, tiny objects, small objects, medium, large, and huge. And these are filtered by an attribute that comes in from the Houdini point cloud. And in this case, if it, say, finds a large object, it puts it into this particular spawner. We can disable this option altogether by using the widgets interface. But the main idea here is that each of these objects has its own template descriptor. So if we go in here, you can see that it has a instance start call distance and end call distance. And for smaller objects, this distance is smaller. If you know a bit about instancing, it basically means that these objects get called out after about 200 meters. When they get far away enough from the camera, they won't be rendered. So tiny objects like small rocks or small bushes will be called from view. On the other hand, huge objects, such as large trees, will instead be called at a much greater distance. They might never actually get called because they probably get called out by world partition before it reaches this distance. Now at the moment, if you want to change this, you'll have to configure it over here inside these spawner components inside the PCG spawner. I'm looking at making this a setting, but I have noticed that the override function on these things can be a bit unstable. It works sometimes, but it also can cause crashes. For instance, in this case, I initially used a single spawner for the RVT decals, trying to override the sorting order for the decals and how they are layered on the terrain. But unfortunately, I was crashing when the attribute, for whatever reason, wasn't present. And that can happen, probably because a grid was empty or for whatever reason. So instead, I've set it up with a bunch of filters. If I find better ways to do this, or future versions of Unreal improve this, I'll probably update it. But that's just one of those caveats with PCG I'm currently dealing with. I just want to let you know, because if you need to change a couple of these settings, you'll have to change it in the spawner at this moment anyway. Okay, that's pretty much it for the spawner. The last thing that I want to tell you is about the RVT decals before we move to Oscar's portion. Basically, right now, if we look in the map, when we look at the decals on the roads, they are basically just a projection into the landscape terrain. This is the RVT texture that we're currently looking at. But the objects themselves, the instances, are actually here. If we go and select some of these guys, let's say we look for something with group 1 in it, notice how there are actually instances here. If we go to our details panel and we select one of them, all these road decals are here in the instancer. However, they are not rendered in the main pass. And this happens because these instances are actually writing into the RVT because they have the RVT textures, the virtual textures here, assigned to them. This is assigned by the PCG tool inside this script here. Let's say I grab one of these. Under, again, template descriptors, the runtime virtual texture right there. So, again, if you want to set up your own runtime virtual texture other than mine, you might have to update this manually because it's actually set up in the spawner. Now, the main idea here is that as long as these guys are writing into the runtime virtual texture, because of this setting down here, draw in main pass from virtual texture, as long as the runtime virtual textures themselves are told to hide those primitives, those objects will be hidden from the main render pass. They will never be rendered. And that's a good thing because these objects can only be non-nanite meshes. If they're nanite meshes, they will never project into the RVT. If you do want to show them without selecting them, you can go to the runtime virtual texture. And there are some volumes in the scene, runtime virtual texture volumes, which are surrounding the scene. And this is what actually enables the runtime virtual texture on the terrain. And if we go ahead and look for hide primitives, you'll find that this is currently enabled. So this has to be enabled on just one of these, as long as they are being referenced by the decal instance. And if I go ahead and disable this, and I then look underground here, because they are currently underground, it doesn't really matter because ultimately they are being projected into the terrain. But you will notice that they are now visible even without them being selected. So if you want to, but that's pretty much it for the PCG spawner. At this point, I'm going to hand it over to Oscar so we can talk about the road decals and road propsing tool that he made. It's going to show you how these objects were placed and how this works. And then after that, we'll talk about how we can take his point cloud of road propsing as well as my point clouds for foliage and combine them together to be output for PCG. So on to Oscar.
Alright, so now I will guide you through how I dress entire road networks with road props and decals using Houdini. But first, allow me to give you all a bit of context. So, during my time at Fracture Labs, my work was to dress the world that the team was creating, while Erwin was building the foundation of our pipeline, effectively the Massive Worlds Toolkit. I developed several plugin assets focused on world building, and we call them plugins basically because they are built under the Massive Worlds framework. One of these plugin assets is the Road Prop Placement tool, or the RPPT. But before diving into it, here are some of the requirements that the team gave to me to build these tools. All these are very straightforward, right? Modularity and automation are pretty straightforward, but the team needed the tools to be artist-friendly, mostly because the art team were unfamiliar with Houdini. This needed to allow quick iteration as the team was still developing the map, and most importantly, they needed to be art-directable. And now, these are the solutions that we found for these problems. First of all, we isolated all art-relevant parameters into one centralized location, in this case the Unreal data table. The Massive Worlds Toolkit allowed flexibility to any change that the team introduced into the data. This could be from the terrain, the road network, or even the assets that they were using. For automation, PDG took care of recomputing everything, and for modularity, we created a custom preset system that I'm going to explain later on in this presentation. These tools follow the 80-20% rule. The tool handles the 80% of the workload, allowing artists to focus on the remaining 20%, which is the creative process and final touches. And of course, provided solutions to assist to the remaining 20%, such as the compositing system. And now let's dive into the RPPT. The Road Prop Placement tool, or RPPT, is a tool to quickly dress entire road networks. Allows artists to configure how each asset on the roads should spawn and how they interact between each other. This tool handles both assets and road decals. The RPPT is built upon the Massive Worlds Toolkit path cache and landscape layers. Using the Massive Worlds loading node, the tool collects the data from the roads, such as location, type, priority, and direction, and uses all that information to properly spawn assets all over the road network. On the big picture, the tool allows you to select segments of the road network and define spawning rules. These rules are pretty straightforward, such as placing assets relative to the center of the road, or to one side of the road, can be left or right side, or even both road edges at the same time and then apply an offset, as you can see on all these videos. This offset can be also relative to the width of the road, so for example you can spawn a line of assets always in the middle of a road lane, no matter the width of the section. You can set these assets to be evenly spaced, randomly spaced by a range, or continuous so one asset follows the previous one. There are options for orientation to make assets point towards the direction of the road or to point toward the next object, such as in the example, and make the cross orientation to be inward or outwards of the road. We can make the assets to be scattered across the road, and we can filter them by landscape features such as cliff, sharp turns, or slope. And you can combine these filters similar to what you would do on a regular group combine node. And there is also priority-based calling, so assets with lower priority are deleted after spawning if they are intersecting to a higher priority asset. We start setting up this tool by configuring the data table in Unreal. But first, I need to mention what is a set of assets. A set of assets is a group of assets that an artist wants to spawn them together under the same rule. These normally range from single assets, variants of the same asset, group of different assets, or even sequence of assets. All assets have individual characteristics that are defined on an Unreal data table by variables. These variables can be global or specific per asset inside the same set of assets. Once all variables are configured, we export them as a CSV file. Then the loaded meshes are analyzed to get bounding shape, height, and size, so artists don't have to configure that manually. Then we assign the values from the data table into the analyzed meshes. This outputs a mesh lookup table with all the characteristics of each individual mesh, and the list of set of assets as well, used to select which set of assets to spawn by a dropdown. Now, let's take a look at this road. It's from the first demo scene of this tool. In this road, I am spawning 21 set of assets, with the tool having 169 parameters. This ends up in over 3000 multi-parm parameters. That is too impractical and confusing, and as well it might hit limits on the Houdini engine. And the solution we found is to encode these rules on strings. And we built this system into an utility tool to use them in any other similar setups in the future. So, all the rules that set how an asset should spawn are grouped under what we call an entry. In the main UI of the road tool, unlike a multi-parm setup, this interface manages parameters for a single entry at a time. The entry being edited is considered the active entry. Once you are happy with the spawning rules, you can push these rules. When you push an entry, the utility tool captures the current state of the parameters involved into the spawning on the main tool, encodes them on a string, and pushes that string into the saved entries multiparm. The encoded strings contain the name, the value, and the type of the parameters. You can see on this encoded string a prefix, which stands by current, on all captured parameters. This is because we use this prefix as an automatic filter to know which parameters set any spawning rules on the tool. Saved entries can be decoded and pushed back to the editing interface. This allows us to quickly edit any saved entries. And you can do this by selecting which entry to configure, pull saved entries back to the interface, updating the editing interface, make the changes you want to do on the current entry, and push back the entry to saved entries, updating the coded string, those updating the spawning rules. So as a general overview of how this encode to multiparm utility tool works, it reads the active entry on the main interface and converts its parameters to point attributes for easy reading and managing. Save those points attributes into encoded strings, and the interface only needs to contain one full set of parameters to edit rules. The others are stored in encoded string form. The editing interface can retrieve and store an encoded entry, and all this is managed by an utility tool inside the main tool, so we can translate this level of control into any other similar setup. Now, you can always save any amount of saved entries into a preset. A preset basically saves all encoded strings under a name and exports it under a CSV file. Here you can see how a preset is applied into an empty saved entries multiparm, and how it populates the multiparm with the encoded strings, the name of the entry, and the preset from it was loaded. And here is what happens on the Houdini scene. The tool is reading all the spawning rules from the encoded strings only. The presets are stackable, so you can add one after the other. You can see here how I first apply preset A with the physical assets and then apply preset B, which stores the spawning rules for the decals on top of that. This allows us to have some degree of modularity, so we can have full and partial presets. They can be quickly accessed from a dropdown, and filters can be applied there as well, for when you have lots of presets. Now, in the example scene that we made for this masterclass, there are 4 road types, each with different presets. In total, there are 72 sets of spawning rules. The tool does not support different presets for different road selections, so we needed something flexible to apply each preset automatically to its corresponding road and be ready to any change on the road network. In this case, all roads use their default preset assigned by the road type. However, you can override the preset applied to each individual road, for example, directly within Unreal. To apply presets automatically to the roads, we group these roads by shared presets using a PDG task. Apply the appropriate preset to each road group, and then merge the results. This approach allows the entire road network to be dressed with variations between the road types. And now, we have automation into the system. If there is a change on the presets, on the road network, or on the assets, simply retrigger the PDG network, and your updates will be applied across the entire map in just a few minutes. Alright, now let's talk about spawning decals. We call them decals, but in reality, these are static meshes. These are much more efficient for Unreal to instantiate and easier for Houdini to manage. Also, because the mesh material writes directly to the runtime virtual texture, and the RBT volume hides all these meshes. This will allow us to instantiate any amount of decals at almost no performance cost, and all is handled by Houdini. In our system, we have detected 2 main categories of decals. The free placement decals are the most straightforward, as they can be any size, shape, and form. They are meant to look good at any point on the road, so mostly they will be scattered. Just to mention, on these decals, transparency is supported. You can see in the images what the decal mesh and the texture looks like. Common uses for these decals are for cracks, patches, potholes, tile marks, wearings, you can name it, all these types of assets that add more detail into the road. But continuous placement decals have some caveats. These are lines or repeated decals that need continuity, but there is a major problem, and is that if the pieces of these decals are too long, on curved sections it would be far too notorious. And we don't want that. It would break the feeling of continuity and bending. So to solve this issue, we start with a long line decal that ties with itself, divide it into smaller pieces, and make the tool sequence the smaller pieces, making a nice bending effect on curved sections. Smoothness can be improved with smaller pieces. Here are some tips to improve further the creation of these decals. Transparency and layering creates more variety and leads to better reusability. It will make each line take into account its own curvature. Like for double lines, you can see that instead of a single decal with 2 lines on it, it's one decal used twice. Pivot placement is so important. Here the decals are pointing towards the next asset, and the pivot is on the center, and on sharp turns, this wouldn't work. So you want the pivot to be on the edge of the decals. Meshes when projected into Unreal RBT are collapsed together and have a sorting order attribute to determine how they are stacked. Their height position is just for visualization, because we're passing the sorting order attribute to PCG and as well to the RBT volume. To set these meshes into RBT, first remember that meshes cannot be nanite. We can set automatically by Houdini to which RBT material this mesh is writing into, and we are using diffuse color, displacement, roughness, and normal. RBT volumes have a parameter to hide automatically all mesh that is writing its textures to the volume. This basically makes all decal meshes instantiated by the tool to not affect performance, no matter the amount. As well as if there is a change on the instances of the tool, the changes will be automatically applied to the runtime virtual texture volume. And this is a breakdown of how the props are being instantiated one after another, and we start with the physical props, then the road lines, the detailed decals, and then some damaged decals to add more variation into the road. And this marks the end of my section. Now, Erwin is going to show you how you can use any point cloud, like for example, the one that the road tool can generate, and compose it and combine it with another ones. So yeah, man, the stage is yours.
All right, so that was Oscar's portion. Now let's move on to the final chapter of this workshop. This is about the composite props HDA and how we can use it to take our point clouds and combine them into a final point cloud to be used by PCG. So here we have the composite props tool in Houdini, and if you have a closer look at it, you'll see that it's basically a bunch of grids, just like the grids in PCG. And we have a lot of these props here represented by their radii and height. Also, if you look closely at these grids, you see that it loads a bunch of files, and each of those files is put into a different group. Basically, this is the group A, group B, and group C, right? Used by PCG. So foliage, decals, and road props. And the idea here is that you can basically use this tool to composite together these points using a bunch of rules that we can predefine as a preset, and then we can execute it to output it for the entire terrain, like in this case. So this tool basically acts like a processor asset. Like I mentioned, it uses presets. Once it's configured, you can recompute the point cloud that it outputs whenever this is required. And it will do so in the same way using the data provided. Now, this means that it can basically load and combine prop point clouds from various caches. It filters these points based on tags and certain landscape layers. It can modify spawn points and then apply rules to these spawn points, such as apply them to certain PCG layers, for instance. It will also prepare the data for PCG, converting some attributes and some of the coordinates that PCG uses. For example, the rotation vectors PCG uses are different than those by standard Houdini instances. Now, this means that the tool has access to several types of data, including the layer data that's been extracted out from the Unreal Landscape. The Massive Worlds Extract Unreal Landscape tool can capture the state of the Unreal terrain into a BGO file or directly into landscape layer information. And next to that, we can also use the biome toolset, which will be released in a future version of the Massive Worlds Toolkit. This particular toolset is capable of creating several different types of layers that we can sample to spawn objects on, or that can be used to cull our objects. For example, an object that should only spawn in the forest biome should only spawn if the forest biome layer has a valid density value. If it's black, it shouldn't spawn, right? If it's white, it should. And anywhere in between, it will have a variable density decrease. So here's some examples of that. For example, here's the same tile in the map, but we have a couple of different layers. Now, the first set of layers that we can actually use, created by the biome toolset, are the core layers. Core layers describe information such as temperature, such as number 1 here. We have moisture. We have the scree, which is basically sand flows in the terrain. And then we also have the water body. So we're basically looking at a lake over here and a shoreline, right? Next to that, like I mentioned, we have the biome layers. The biome layers, in this case, describe where each biome is located, and we can actually manually paint these in Unreal as well, granted that afterwards we extract them out to Houdini, so Houdini will be aware of that change. Now, the extraction tools are not currently included in this version of the toolkit. They are in version 1.1, the previous build, but I've made some optimizations to them and some improvements, so they'll be available in the next build, which should be released in a month or two. Now, if we look closely here, you'll also notice that these layers slightly overlap, meaning that they aren't purely negatives from one another, meaning that you can overlap some biomes, and basically means that you can have some foliage from two biomes exist in the same place. And then finally, we also have these sub-biomes. So the sub-biomes are the actual materials in the terrain, such as the sand or the dirt or the grass, plants or stones. And here you can see that they exist all in the same space, but they always add up to 100%. And this is important because they're weighted layers in Unreal. And then next to that, we can feed the compositing tool point clouds. So as you saw in the previous animation, these are basically point clouds that contain the information for all of the props that we're trying to spawn. And this information is basically comprised out of various attributes. We have the transforms, such as position, rotation and scale, but we also have other information such as the SP attributes or spawn point attributes. These are attributes that the compositor is specifically looking for and that are then passed on through to PCG. We'll go over some of these in a moment. Here's the basic idea on how the compositor functions. So on the left here, we have the input configuration system. Basically, you are potentially able to feed the system one file, multiple files, or make it automatically scan for files with certain tags. And the tool will be looking for these to filter out specific files that it wants to load and then skip the other ones. This is a lot more efficient than loading everything and then filtering the points afterwards. Now once these are loaded, we'll have a bunch of points and then we can filter those by blueprint spline tags as well. So we can actually draw a couple of areas in our map. And I've not demonstrated this in our demo session, but it's also possible to use a blueprint spline and then use the extract blueprint spline tool to mark out an area and then filter out specific objects based on specific tags. Not to go too deep into this because I didn't actually demonstrate it, but the basic idea could be I can draw a curve in Unreal, one of these splines that I can place somewhere in the map, like for example this spline here. And I can add a custom string to it, such as trees. And then the idea is that this can be saved out to a cache on disk using the extract blueprint spline tool. And then the composite props tool will read this spline and automatically call out any prop in this area that has the tag trees in it. So, basically it's a way to call out specific props in specific areas. And it also comes with a selection proximity as well, so we can set it to 20 meters and then we'll delete objects 20 meters away from this in a increasing manner, or decreasing in this case. If we go back to our slide though, so once we filtered out for these spline tags, we can then go to the main compositing portion of the system. Now in this case I have an example of the compositing rule that I've currently got in place in our demo scene. Basically I'm loading two sets of foliage point clouds. We have the forest biome point cloud and we have the coastal biome point cloud. These are both being loaded across the entire map. Basically I'm not culling them based on their location. I'm telling the system, the biome spawner, to spawn them across the entire world. Then we can filter them by the biome layers. So in this case, this particular point cloud only exists wherever the forest biome is viable. And this one only where the coastal biome is viable. Next, we'll filter out the roads, meaning that if a road exists somewhere, it's going to remove any of the plants and trees that intersect with these roads within their hard bounding range. The main idea for this is that we can actually move the roads, because they are procedural roads after all. If you've watched my previous videos on the Massive Worlds Toolkit, you probably already know this. But the idea is that if we move a road, we want to move the places where the trees are culled. So the place where the road used to be, in that location the trees should be returned. But the place where the road now is should have them culled out. Simple enough. And then finally, we want to make sure we can do some filtering by overlap. Basically, this works by filtering based on tags. So we can basically say, for instance, the forest biome has the tag FB. The coastal biome has the tag CB. We have RB over here for road barriers, and then we have road props on this side. We're going to ignore decals because decals don't really call out anything, right? So the idea is that the forest biome is going to get called out by road barriers and by road props. Because if we ever have a road barrier or a power line or something somewhere, those probably should take precedence. So the trees and the bushes and whatnot that are in the way and intersecting them will be culled. On the other hand, here we have the coastal biome, and this one gets culled by the road props and the road barriers, but also by the forest biome tag. Meaning that if we have an overlapping tree or bush or rock from the coastal biome with a forest biome prop, the coastal biome prop will be deleted first. So this way we can basically combine our two sets of data and allow them to coexist. And this can of course be expanded as you integrate more point clouds. As for the road props, we're basically going to assign those to a different layer. Specifically, the road barriers are going to be added to output C, and the road props over here are going to be also added to output C, but the decals are being split out into output B. So even though they come from the same point cloud, we're splitting them up into different outputs so they can be fed to the correct PCG layer. Now, as for the interface of this tool, this is basically the same or very similar between the composite props tool and the biome spawner tool. Just to give you a quick overview here, we have the preset mode. We have a place to define which area to process, which is the landscape project name. We can filter caches that we want to combine. We have the compositing rules, and then finally we have the output configuration for the tool. I'll go over these quickly and we can have a quick look at the tool in the editor, but I won't be going too deep into this. This video is already long enough and I'd like to make a more detailed video about these tools in a future video. Okay, so the first thing that we want to do when we start up this tool is to define an area to process. Basically, we can make the tool operate on the entire map, but if we are actually going to composite our rules together, we don't have to, right? We can actually look at a very specific area of the map and only work in that area. So over here, we can change our spawning area and set which tiles we actually want to work on. And then next, we can also choose how we want to load our files. Besides being able to load a single cache or multiple caches, we can also use an automatic system that filters out these files by tag. So in this case, we're looking at the SP loader tag list, meaning that these are the tags present on the detail attributes of our caches that can be filtered out before we actually load all the points in the point cloud. So what we can do here is actually grab a tag from the list and then push it into the sub list below. And if they are present, it will load them. We also have some basic combinator logic, so we can add an AND symbol in there. So say both tags need to be present for it to be loaded. And you can see here with those rules, we are currently loading 2 of our point clouds. Now, a quick overview of these SP loader tags. There are 5 types of tags that we can define, and they're basically prefixed with these particular elements. So for example, we can say the CNT, which is the name tag for the cache, or cache name tag. We also have the HDA tag, which is a tag that we can set that defines which HDA created that point cloud. For example, Oscar's tool, which is the RPPT, could have the name tag RPPT, or road propsing tool, right? Then we have the preset name, or rather the preset that was used to generate a particular point cloud. So the forest preset could have the name forest, as the SP loader tag. And then finally we have the spawner tag. And the spawner tag is basically a custom tag that we can add to our spawners. For example, I will generally add the tag global prop to the point clouds for the trees, because those are often the trees that I'm spawning across the entire world, and they aren't local propsing. And then finally there's the enable tag. If that's 1, it will be used. If it's 0, it will not be used. So we can actually invalidate certain point clouds, leave them in the folder, but never have the system load them. And here's basically an idea for how this will work. For example, here we have 6 caches in our folder on this landscape here. And currently we are loading these 4 files, right? And these are based on the rules that I was setting up in this particular video here. So you can see that we are loading the global forest biome. We are loading the global coastal biome. Then we are also loading the road prop placement, which has the cache name tag alternate. And we are loading the barrier example. So in this case, we are loading this particular cache, road props alternate, but we are not loading road props default. Okay, cool. Now next, when it comes to the actual point clouds, once they are loaded, we also have a bunch of these spawn point attributes, which provide key information. There is a help file included with the tool. You can find all the attributes there, but I'd like to go over a couple of key ones here. For example, we have the spawn point name, which defines the name of the object or the object set that that point belongs to. We have the hard radius and the radius. These are basically the radius of the object, and this is used for overlap detection. Now the difference between hard radius and radius is, if you think about it in terms of a tree, the hard radius is basically the radius of the trunk of the tree. It's the hard object. And then you also have the radius, which can be the entire canopy of the tree. We might be able to overlap canopies in some cases, but we probably don't want to make the trunks of trees overlap, because then they'll literally just be inside one another, right? We also have the height of the object, and this can be used for culling, for overhead bridges, for example. So we never spawn a tree underneath a bridge if it won't fit. Then next, we have the SP tags. Now the spawn point tags are very important when it comes to filtering out points and making points recognize each other. They are basically a series of string arrays that combine to identify objects in the point cloud. We also have a bunch of other attributes down here which are used directly by PCG, but also by the biome spawner tool, for instance. So we have the attribute here that tells if the object should align to the terrain. If it's 0, it will not align to the terrain, but if it's 1, it will reorient and make the actor match the orientation of the terrain. So whatever gradient in between there, you can make an object either stand straight up or angle with the slope. And PCG actually also uses this. We have the inset variable, which determines how far this object should be inset into the terrain. For example, a trunk or a rock may need a slight inset in order for it to properly sit on the ground. Otherwise it might seem like it's floating, right? Now, this is set on the data table in Unreal and passed through the system onto PCG. So when PCG moves the object up or down, if the terrain changes, it always respects that inset. And then here we have the max cull weight attribute. Again, this is used by PCG to cull the object if the removed layers are applied. And then finally, for the RVT decals, we also need to pass through the sorting order. This is important if you have different decals that are being projected onto your terrain, and it determines which ones end up on top if there's any transparency present. It also helps to make sure that they sort properly. For example, any asphalt detail that you want to project onto your roads should probably be below your road lines. Now, if we're talking about the spawn point tags, They are basically a set of strings, and they combine together into the final SP tags attribute. They are string arrays, and if we look at the individual strings below, you can actually see we have one for biomes. So if you want to have specific objects exist in certain biomes, you can add that into the tags biomes string array. There's the object tags, which are tags provided with the objects. We can actually set that in the data table for the biome spawner, for instance. And we can say, for example, that certain types of trees are a certain types of species of tree. Or we can say it's a certain type of decal, like road line or detail decal or pothole, that type of thing. Then we have the spawner tag again. So the spawner tag, like I mentioned before, can be something like global props, or it could be road props. So it's a general catch-all type of tag that can be applied to a certain point cloud. It doesn't have to per se be something that's created by a certain HDA, right? But it can be useful to recognize these points, and it's fully customizable. Then we have the size tag. This directly relates to that size category system in PCG I mentioned earlier. So we have 5 values it can take: tiny, small, medium, large, and huge. And again, this is used by PCG. And the last one here is the type tag. It's a general category that you can kind of set things like trees, rocks, and more importantly, RVT decal. If you feed it the tag RVT decal, it will automatically detect that object as an RVT decal and shunt it off to the correct output in PCG. So this is what you need to give it as a tag to make the system output objects as an RVT decal and not a regular instance. Now, if we're looking at the road props tool from Oscar, these are the attributes that are being passed through by the compositor to PCG. Specifically, if we make sure that the RVT decal attribute is present in our SP tags string array, then it will automatically assign the PCG RVT decal attribute to the output, and it will set it to 1. Likewise, if we feed it a sorting order attribute, it will also output it for PCG as PCG RVT sorting order. So this is important for PCG to recognize what to do with the instances, and it will allow it to know when an object should be output as a decal and what order it should be sorted in. And then from there, if we take our layers, our point clouds, and our attributes and tags, we can now define our rules. So this is basically a list of rules that are operated in sequence, and we can define a selection of various tags and then apply different rules to them. So for instance, I can say I want to use the name alternate with road prop placement and road props to select just the road props from the alternate cache, and then we can apply some rules to that. Now in this case, the spawn point tags and the biome layers are used to make selections. We can do various things, such as remove points by obstruction, right? We can tell an object to be removed by another object with a specific tag. We can filter by biome density. We can re-snap objects to the terrain, or tell it not to. And we can also apply certain PCG rules that PCG will take into account, such as down here. We can tell it to not re-snap to the terrain or not realign to the terrain. And also which PCG output group that selection belongs to. After that, once we've configured our rules, we can go to our preset saving mode. We can also load from here, but let's say we want to save it. We can give it a preset name, the folder that we want to save it in, and then we can click save. And with that, it will create a preset file that can then from that moment be loaded by the tool, or alternatively, it can be loaded by the task manager. And when the task manager loads it, it basically loads that preset up, applies it to the tool, and then computes out the result for, let's say, the entire world, which is kind of the entire point, right? We configure our rules in a small area, and then we can apply it for the entire map in a background operation. So before we actually go to the final part here, let me quickly show you this live in Unreal. I'm not going to go too deep into the settings, but I at least want to show you how it functions. So now that we're back in Unreal, let's have a quick look at the various tools in here. I'm not going to go into detail, I'll just go over the basics. I will have another video for this particular topic later. So over here in the background, we have the Composite Props tool. Now the Composite Props tool, like I just mentioned, is used to composite these props together, and it takes the caches from the biome spawner tool. It takes the caches from the barrier instancers, which are used to create these little barriers next to the roads, separate from Oscar's RPPT tool. And then of course there is the RPPT, which is not included in this scene, as that one is, well, it's Oscar's tool. It's the tool from Fracture Labs. Now I might be able to include it with the commercial versions in the future. I'm currently trying to work that out with Fracture Labs, but for the time being, that is not, something I can share with you. Anyway, if we have a look at the Composite Props tool over here, you will notice that it is actually loading these particular caches. So for the first layer, layer A, it is loading the global coastal biome and forest biome, and we're spawning these amount of points. For layer B, we are loading the road props alternate cache, and for layer C, which is the road props next to the roads, so these are the decals and these are the props, we are loading the barriers from that barrier spawner tool, and we're loading the road prop alternate cache, but only the prop components from that cache. Again, we already went over this just before, so let's keep moving. Now if we have a closer look at this tool, let's say we activate the tool. In my case, I've already activated it by simply clicking rebuild. And I'm going to expand my interface here. So the first thing to note is that it's already running a bunch of rules. You can actually configure these rules in Houdini or in Unreal. Both work. Perhaps the interface in Houdini is just a bit easier to work with. The Unreal interface is a bit clunky, frankly. You got all these, you got this going on, these sliders. Either way, the tool is designed to function within Unreal, regardless of interface issues. In fact, I've designed this tool to work specifically in Unreal. There's also a help card over here. You can find a lot of information about the different attributes and how they are used by the tool, similar to what I went over just before. But let's go ahead and first make sure that we have a preset loaded. At the moment the tool is already spawning something, so there's definitely a preset loaded, but I'll just show you how you can set that up. Let me go and minimize a couple of these things. I don't need everything open here. Unreal likes to open up every single tab. Okay. Now, what I'd like to do is purge my current preset. So I'm going to go down to the compositor settings down here, scroll down, and I'm simply going to delete my current composite rules. Now if I do that, it will still spawn my objects, because currently it is being told to spawn specific objects, but it will spawn all of them, right? At this moment it is not culling out anything, and we're going to get these yellow props, which are beech trees, as well as these forest props, all in the same place. They're going to be intersecting with one another, and yeah, that's not really what we want. Right now we have a lot of stuff in the same space. We got rocks in the roads, in these pathways. That doesn't really work, right? So let's go ahead and actually load up our preset so these things are handled. Or we can actually configure this ourselves. In fact, let's start out by doing that. let's go ahead and go down to here to the tool mode. And as long as the tool is set into output mode, we should be able to see our results change as we edit things. So I'm going to go scroll down, and under the compositing settings, let me make it a bit bigger. I'm going to add a new composite rule. So let's expand that. And the first thing that we need to do is specify what we actually want to composite. Now by default, and you already notice that it's doing something, it's trying to select everything and it's applying one of the composite rules to it. That composite rule in this case is that it should call these objects by roads, and that it should also do a couple of other things like snap it to the terrain and such. So even without selecting anything, I am currently culling out my objects on the roads. But it's still not filtering out, for example, the beech trees and the other trees based on biomes. Now let me make a more explicit rule for the roads, for instance. If I go over here, I can grab my tags. So I can grab this list, and here's the list of all the tags that are present on the objects that we are currently loading. Now if this list isn't available or isn't updated, you might have to go to the top and click rebuild, because Unreal's interface, or at least the Houdini engine's interface in Unreal, doesn't update automatically. It has to be refreshed using a rebuild. Now over here we can then say, let's grab our props from the road prop placement tool. Okay, now I'm going to push this into my selection on our first rule. At this point, all the props from the road prop placement tool are now being selected. Now at the moment we see no road props, and that's simply because they are being culled by the existence of this road here. Next, let's scroll down and let's say do not cull by roads. We turn that on, give it a second update, and now you can see all our road props or our decals are currently being spawned. It's also trying to spawn some other objects which are currently not in the project, so that's another thing. But you know, PCG will ignore those anyway, and so does Houdini. Next, we might want to set these objects to be added to a specific group. But remember that these particular road props contain both decals as well as the actual objects next to roads. There aren't too many in this particular tile, but that's okay. What I want to do at this point is add a couple of rules to this particular selection. I want to make sure that I'm only selecting the decals, for instance. So if I go up here, I can set it to append mode. And then under my cache tag list, I'm going to grab the RVT decal tag. Let me find it. Here it is. And I'm going to append that to this particular selection. So at this point, I'm basically telling that the RVT decals of the road prop placement tool should not be called by roads. Okay, that's good. So that means that now I can also go here and set this to output group 1. So at this point I've configured the RVT decals to output to that particular group. Another thing that I might want to do is make sure that it doesn't realign them or doesn't call them by slope. For particularly the RVT decals, this might be something that we want to disable. So we can go in here and turn these on. Maybe it's probably still okay for them to re-snap to the terrain, but other than that, let's keep it like this. Okay, so that's one. Now, let's say we want to do the same thing for some of our trees, right? So I'm going to go and add another rule. I'm not going to go through the entire settings here. I'll just set up 2 rules and then we'll load up a preset and then we'll call it a day. Like I said, this is a simple introduction. I'm not going to make this too deep. So let's say I want to prevent the beech trees here from spawning in the forest area. Or alternatively, no, let's actually make the forest trees not spawn on the beach, because over here we have the beach and we don't want these trees to spawn there at all, right? So I'm going to grab my tool, go down to rule number 2, and let's find the, let's say, forest biome props, or perhaps, let's say, the cache name tag global forest biome. This one will do. And I'm going to push that one into the second selection. Okay, so now we're selecting these trees. Next, we want to cull them out based on the biome that they reside in, or in this case, where they shouldn't be. So I'm going to go up here to my biome list, and there's a bunch of different options here. There's the coastal biome. Coastal inverted is basically, if you take the coastal biome and you invert it. I created this specifically for this case. Now, coastal inverted is basically the opposite of the coastal biome, since there are only 2 biomes in this scene, and I didn't actually design this map with just 2 biomes in mind. I had to create a separate biome specifically for anything that isn't coastal, because otherwise some areas of the map, like over here, are actually supposed to be a desert, and there would not be a forest there anyway. Just something to keep in mind. On the other hand, what I could also do is I can say I want to select the coastal biome. In this particular case, this would probably work. And then I can say cull by that biome. But since I have a specific layer for the forest, let me just use the coastal inverted layer for now. Okay, so let's go ahead and push that into inside this biome only. If I do that, it will load the layers from the hard drive, from the cache, and assuming that I don't add an and symbol here, it will filter out the trees in the coastal biome. If there's still a little bit of forest biome present in this area, it might still allow the trees to spawn there. But you will notice that now the trees at this part of the beach are all gone, right? Similarly, we can set up the same thing for the coastal biome, make it delete the coastal trees from the forest biome effectively, only allow them to spawn in the coastal regions. That's the basic gist of this. Now the idea here is that you're basically going to set up a bunch of rules to control where objects are allowed to spawn. You can also do things like make objects cull by other objects with a certain tag. So, for instance, we can make our road props cull out the trees, right? By simply adding the tag for the road props in there. So if we find the road props tag, we can actually add that in. Let's find it. Where are you? Road prop. And again, we can just type this as well if we want to. But we can say add the culling filter for our trees. So now if there are any road props anywhere, and unfortunately in this part of the map there just aren't, but if there are any trees overlapping a road prop, those will be culled out. Okay, so now let's go ahead and load up a preset as well. So we actually have a proper rule set applied, because at the moment it's only loading a couple of data sets, depending on where we're looking, right? Let's go to our top of the tool. I'm going to switch it over to preset mode. This will disable the output of the tool. It won't output any trees or whatnot. But I basically have to switch this over so it's not trying to cook the objects out while it's loading in a preset. It just makes the tool a bit more stable. Now let's go ahead and grab our preset list. I want to make sure I have the alternate preset over here. It's already pushed in here, but again, just like before, we can basically click on replace preset on this button. We'll push it in here. And now if we turn on this toggle, it will trigger the loading behavior and load up that preset. Now you'll notice here that now down below, all the rules are now reapplied. So basically this is the same thing that happens inside the task manager when it wants to run this node, which currently is invisible, so let's bring it back. When it wants to run this node in the task manager. Now the task manager is over here, and basically what's going to happen inside this node is the following. So if we look further down here, the task manager basically allows you to run the node not just locally, but also in the background using a PDG task. So the PDG, or procedural dependency graph in Houdini, basically allows me to execute the systems of the toolkit in the background, or potentially on a render farm in future iterations. Now to make this work, I have a wrapper asset that uses my node presets node to push the preset into the composite props asset, and then using a Python script, it will trigger this node to cook. The reason I'm doing that is because you don't want to make a preset apply while the node is already evaluating, because that doesn't go well with Houdini's memory. The best way to make it work is to just render out this chain. We basically say PDG task gets booted up here. Then the preset node over here will load the preset, apply it to this asset here, and it will load up that particular preset onto this node. Then, after that, once this is done and the node has been configured, its interface has been configured, the execute function here triggers and tells this node to cook and output a file. We can also take some of its data and output it out a second channel here, which will then be useful further on in the PDG graph. So the way how I've set this up here is simply by making the left chain prepare this node and then trigger it. It means that the settings on this node are configured first, and then the node is cooked. And this happens in the PDG. So if we look at the PDG, basically, we're going to be running the composite props over here in the background, and then it's going to run this node down below, which outputs the data from the composite props into the Alembic point clouds. The reason that I've split this out into the PDG task is simply because we can easily get up to hundreds or thousands of point cloud data files, Alembic files, that need to be rendered out. So having that as a parallel task, which the PDG is great at doing, is basically a better method of setting this up, at least in my opinion. And then on the right, we have this node here, which collects the data from both composite props data sets, specifically the loader grid information, combines it together and outputs it as a single file. This is how this single file can know the data from both data sets simultaneously. So again, as a simple recap, the nodes up here compute the composite props data. Then we have a wedge that splits that into multiple tasks, one for each grid that we need to output. And that gets then run over this Alembic data table export node here, which will render out each grid to an Alembic file. And of course, you can actually go and have a look at how this works yourself. You can do this in Unreal by running the task manager. You simply have to boot it up using rebuild. If we jump over here, we have the interface, and down below we have its settings. So if we just scroll down, we can see here that we can tell it what we want to recompute. For example, we can tell it to recompute the global props, the foliage for our world. We can also tell it here to recompute the composite props, and if we want to output the alembic files, and if we want to output the loader grid file as well. Usually I output all of these together, but it depends if I need to regenerate the loader grid file or not. Once that's done, just click on reassemble file paths down here. This makes sure that the tool can find its subcomponents. And then either click on this button here to render the global props, or alternatively, you can go to the top interface here, make sure you have the output selected, maybe disable these, and then you can click on dirty all to reset the tool and then cook output. So if I trigger that, it's going to start cooking these tasks in the background, similar to what I was showing you over here. It's going to start rendering out our alembic point clouds. Now I'm going to leave it at that for now, because this is going to take a moment to compute, and I'd like to wrap up this course at this point. I'll follow this up with another video later to go into more detail on the biome spawner, the composite props tool, and the task manager in the future. So at this point, that's pretty much the end. So let's do a quick outro. You can find the latest information about the Massive Worlds Toolkit on my website at houdiniacademy.com/massiveworlds. Now at the moment I haven't updated the website yet for every single function that I'm adding. I'm still mostly advertising version 1.1, but still there are a bunch of features currently in development. So if we quickly go over those, I'm working on a procedural biome distribution pipeline. I've got an interactive terrain sculpting and post-processing tool, which uses external height map stamps such as tangrams to help us generate our terrain. I'm working on an improved landscape import and export pipeline. I'll probably release that in the next build of the toolkit. We've got the workflow integrations for Perforce and render farm support. Hopefully I can get that in, but at least Perforce support, that's my goal for this particular release. I'm also working on a procedural settlement builder. That one's about half done at the moment, but it still misses some key components. So we have a procedural road sign builder, which allows us to place road signs next to roads, which will point to point of interests, which you can define across your map. So that's pretty interesting. And other than that, there's a bunch of other general improvements and more that I'm currently putting into the next build of the toolkit. It's really designed to be suitable for large projects and can be handled with customization and art direction in mind. Now, like I mentioned before, if you're planning to get the toolkit for your projects and it's a commercial project, you probably want to have a look at the commercial licensing, because the license that I provide to you via the patron is only for evaluation and non-commercial uses only. The moment you get past a certain threshold of, let's say, revenue that you make per year, or people that use the toolkit in your team in some way or form, you will need to buy a license from me. And I'm offering single and unlimited project licenses in both black box and source code versions. Please go to my website at houdiniacademy.com/licensing to get more information about what's currently on offer. Now, for the toolkit roadmap and update logs, you can also go to my website, or you can go to my Patreon. Now, my Patreon currently has the most up-to-date version. The website will follow soon. Next to that, there's my YouTube channel at Houdini Academy. And you can also find more information here about my previous masterclass. The foundation module is currently free and available for everyone to use to learn Houdini from complete beginners out to refresher courses. And finally, so you can also go to my Discord channel. The open channels, public channels, are available via this link. And if you join me on Patreon, you'll also get access to the Patreon exclusive channels as well. And that's pretty much it. I want to thank Oscar for co-hosting this workshop with me. It's always a pleasure to work with you, Oscar.
Thank you so much, Erwin, for inviting me to co-host this masterclass. It's been an absolute blast preparing it with you, and I hope everyone enjoyed it as much as we did working on it.
You're welcome. And of course, as well as the patron backers that back me on my Patreon. Without them, this project would have never gotten off the ground to begin with. And yeah, thanks for watching this video. I hope you look forward to my next tutorials and workshops. I'll be trying to go deeper into the spawning tools. And of course, as I release more updates, more videos will become available for those as well. So keep an eye on my channel and on my Patreon. In the coming months, I will be releasing more updates and more vertical slices for Massive Worlds version 1.2. Thank you everyone for watching, and I'll see you in the next video. Have a good one.
Bye bye.